Low-carbon heat networks, an opportunity for communities. Based on a study by Community Energy Plus entitled Low-Carbon Heat and Rural Fuel Poverty, Lessons from Across Europe. This presentation aims to introduce the topic of low-carbon heat, in particular looking at how low-carbon heat can be delivered through heat networks and at the opportunity for projects on a community scale. Drawing from examples and research from across the European Union, key lessons from policy and practice will be explored, to examine the UK's progress in low-carbon heat and to look at opportunities for communities to play a greater role into the future. Background to the study. The presentation draws from a wider study by Community Energy Plus, commissioned by the Eager Charitable Trust. Community Energy Plus aims to provide local solutions to fuel poverty, working in communities across Cornwall to build awareness on sustainable energy and assist with the delivery of renewable energy and energy efficiency projects in community settings. The study looks to bring together the three related topic areas of low-carbon heat, fuel poverty and rurality. Low-carbon heat is recognised as an essential element of achieving carbon emission reduction targets, with demand for heat representing a significant proportion of overall energy consumption in the UK. Fuel poverty affects 11% of the population across Europe, including 2.35 million people in the UK. The most broad definition defines fuel poverty as the need for a household to spend over 10% of their disposable income on fuel to maintain an adequate standard of warmth. Energy prices are a critical factor for affordable heat, particularly for rural areas where access to grid-supplied mains gas, as the cheapest fuel source, is more limited. Low-carbon heat sources offer an alternative to conventional fuel sources, with great potential to see cost savings into the future. Rural areas have particular challenges, where the decreased density of rural housing and increased sparseness can affect access to services and perceived viability of projects, such as for insulation schemes or district heat networks. In the UK, the average fuel poverty gap, which is defined as the reduction in energy costs required to lift a household out of fuel poverty, is £820 for rural areas, compared to only £304 for urban areas. Rural homes are less likely to be heated by grid-supplied mains gas, which is the cheapest fuel, and are more likely to have solid walls, of which statistics indicate 90% are not insulated. Low-carbon heat. Not all low-carbon heat is derived from renewable energy sources. Renewable energy sources are defined by sustainable natural processes, with resources being replenished more rapidly than they are expended. Low-carbon heat, on the other hand, may relate to the fuel source or to the technology that is being used for delivery of, in this case, heat. There are a number of different technologies and fuels considered under the umbrella term low-carbon heat, including heat pumps with energy sourced from the air, ground or water, bioenergy, including biomass and biogas, solar thermal and geothermal. Bioenergy represents the most widely used renewable energy source for the delivery of heat across the European Union, primarily through the use of biomass, but increasingly so from biogas. Renewable sources of energy, including wind, solar, tidal and hydro, can also generate renewable electricity that can be used for heating. Electrification, where heat sources are moved to make use of renewable and low-carbon sources of electricity, represent an opportunity to reduce carbon emissions. This can be through the use of more efficient technologies such as heat pumps, which have significantly higher efficiencies than traditional electric heating technologies, and by substituting electricity generated from the combustion of fossil fuels with electricity derived from renewable resources. Heat can be delivered through individual installations, but increasingly recognised are the benefits of using a network as the mechanism for heat delivery. There are a number of potential benefits to using heat networks. They can facilitate the rapid take-up of renewable and low-carbon heat, provide cost savings on heating infrastructure, increase efficiencies in heat production, utilising a central boiler for example, and overall reduce carbon emissions. Flexibility is another important advantage of district heating systems, where heat solutions can make use of a variety and combination of fuels and be adapted to available local resources. Low carbon heat and fuel poverty. From the graph, it is clear that a high renewable energy source share in heating does not guarantee low fuel poverty levels. However, what can be seen is that leading countries including Austria, Denmark, Estonia, Finland and Sweden do indicate high renewable heat deployment levels alongside low reported fuel poverty levels. In other countries with high deployment of renewable heat, but with high fuel poverty levels as well, there are a number of contextual factors to suggest why this might be the case. Central and Eastern European countries have been recovering from deteriorated building standards and insufficient welfare systems left post-communism. Overall, poorer quality housing in southern countries and wider economic issues mean that low-carbon heat cannot be a solution in its own right. Certainly, there are lessons to be learned from those countries where there is significant levels of low-carbon heat and low levels of reported fuel poverty. Lessons from Europe: a history of successful practice. In many countries with high levels of low-carbon heat, the widespread adoption of heat pumps and heat networks started before the liberalisation of the energy markets. In these cases, investment subsidies were not involved in the extensive development which has taken place. For example, district heat in Denmark and Sweden, where heating companies were owned or controlled by municipalities, with risk reduced through planning and regulation of the heat supply. Access to grid-supplied fuels and availability of resources have played a major role in shaping how and when countries have succeeded in deploying low-carbon heat. Sweden, Denmark, and to a lesser degree Austria, all suffered spikes in energy costs following the oil crisis in the 1970s. The resulting drive for energy security saw a deliberate and strategic shift away from oil towards self-sufficiency through biomass natural resources. These natural resource endowments have supported widespread uptake of low-carbon heat, while limited natural resources and widespread grid-supplied gas in the UK, Ireland and the Netherlands correlate with their position of having the lowest shares in renewable energy for heating and cooling. Countries showing the highest deployment of low-carbon heat are also characterised by long-term government support and policy stability. Coherent policy frameworks have fostered long-term confidence and investment, with consensus across political parties in how to achieve long-term energy security. Decentralised policy, with a strong role for regional administrators, has allowed policy mechanisms to be tailored to local concerns and resources. In the UK, however, early market liberalisation and a history of centralised control has altered the scope for local authorities to direct the development of energy systems, in particular district heat, and energy assets have been consolidated under the control of a small number of companies whose international scope challenges development of locally specific schemes. In countries with high levels of renewable heat, taxation, incentives and subsidies have been a positive driver. These have included mandatory connection to district heat networks, compulsory zones for connection with bans on the installation of fossil fuel-based heating systems, heavy taxation on fossil fuels, and subsidies for the installation of heat pumps or biomass boilers to support expansion. Strong regulation, product and installer standards have also been present, with clear and accessible information supported by awareness campaigns, increasing awareness and consumer confidence. The UK's position on low-carbon heat. In the UK, the penetration of renewable technology remains low, in part as a direct consequence of historically ample supplies of natural gas and extensive availability of the transmission and distribution network, as well as the comparatively low upfront costs and efficiency of gas boilers. Current levels indicate penetration of renewable heat at only 5.54% compared to a target of 12% for 2020. Alongside improved energy efficiency standards, the deployment of low-carbon heating systems will be essential in meeting carbon reduction targets. With electrification a key part of future scenarios, renewable energy generation will also play a role in meeting an increased demand for electricity. Targets can be seen set out in the table, however there currently remains a gap of 47% between reductions required by the fifth carbon budget period and the UK's current trajectory. Community energy. The reduction of tariff support and alteration of planning regulations, particularly for solar and wind, has seen a stalling in community energy projects in the UK. The renewable heat incentive still remains for low-carbon heat technologies such as biomass and heat pumps, and there is an opportunity to refocus community energy projects. However, there still remains barriers to capital finance, knowledge and skills to implement this. Take-up of low-carbon heat on significant scales in other countries has been driven by strong national and regional policy and incentives, for example by using mandated schemes and bans on alternative forms of heating. However, beyond this, community ownership can also be a key driver in enabling low-carbon heat projects to work financially. Research has shown that in some examples, community projects are estimated to offer 12 to 13 times as much value to be reinvested back into local areas as there would be through a 100% commercial model. This additional value factors in the wider social and environmental returns, such as the use of local resources, as well as sales of heat and electricity under control of the community, with profits returned to the local economy. Case studies from across the EU. Low-carbon heat networks have been retrofitted at a village scale in rural parts of Europe, and there is demonstration of a wide range of low-carbon solutions being used. In Germany and Austria, the concept of the bioenergy village has been a key driver for the rural development of low-carbon heat. Bioenergy villages can contribute massively to the decarbonisation of the rural energy supply, from 56% to 97% in carbon reductions having been achieved. Despite lower energy demand densities in rural areas, all these villages have trusted in district heat as a mechanism to gain economies of scale and make a fast and collective switch to renewable heating, as well as to keep an added value in the region where fuel sources are supplied locally. Examples of technologies being used include biogas with combined heat and power, biomass using wood chip district heat, solar using both PV and solar thermal, heat pumps and wind. The mix of incentives for citizens, be that economic, social or environmental, which drive support and involvement in a transition to low-carbon heat, is an important factor in gaining maximum participation, particularly for a district heat network where a minimum commitment from households in the community is essential. Many rural areas have reached a position of economic downturn, are marginalised from grid access and other infrastructure, and find it difficult to retain economic value in the region. The incentive for low-carbon heating is that it can be a cheaper fuel source, which helps households move away from imported and often more expensive fossil fuels, thus reducing fuel poverty. Socially, it can bring investment and jobs to a locality and help retain value for landowners as local fuel suppliers and for industries within the area. There is a drive for energy independence to reduce reliance on imported fuels and exposure to the uncertainty of future price rises. Often, there is also a desire to be more environmentally conscious as well, and to improve quality of life, where re-establishing the community can be an important factor. Further factors may be political support, regional development programmes, or external research value for universities, private companies and other organisations. The availability of natural resources, particularly where they are going to waste, is often a key driver for the development of a project. Finance for developing low-carbon heat is an essential consideration for projects. The case studies reviewed have utilised a mix of funding sources, including grants, subsidies, loans, and private investment. Many have made use of EU programmes such as the European Regional Development Fund, with a number of national, regional, and municipal grants and loans playing a significant role. Private companies and organisations, such as installers or energy companies, have also taken a role and invested in projects. There is a mixed approach to citizen contributions, with some projects requiring a customer fee to connect and others not. Both ways have resulted in successful projects. It is often the case that where a farm owner or landowner is driving the project, they may make significant investments to then earn a profit from selling fuel or sometimes setting themselves up as a heat provider. From the barriers faced, lessons show a clear need for effective communication, awareness raising, education initiatives and visits to other projects. The role of trusted and strong local stakeholders, such as landowners, farmers and mayors, to drive the project and remain involved is often a determining factor in the success of projects. Some of the barriers highlighted include the administrational workload and speed at which the project can secure funding, which could be a hindrance. Access to experienced partners, advice agencies and good working relationships with the local authorities have enabled projects to get off the ground. Making use of synergies to bring added value to existing land use and occupations has helped improve acceptance and participation in the communities. Case studies from the UK. Overall, the community-led approach is not as cemented in the UK, in public culture or in policy. However, a number of case studies identified do display many similarities to those projects examined from across the EU. The first example is the Springbok Estate in Surrey. Woodchip District Heating has replaced oil boilers for 20 homes on an estate, where a number of the existing boilers were identified as inefficient and in need of replacement. The estate does not have access to grid-supplied gas, and the location is in a heavily wooded area with wood fuel produced locally. 2 backup oil boilers are used in the case of maintenance or issues with the woodchip boilers. The cooperative raised a total of $425,000 through 2 community share offers. Early finance for the project was secured through short-term loans from Care Assure, the residential home, and the cooperative directors in order to keep the project on track. Heat is charged at individual metering points where the heat enters the premises. Therefore, there is a big incentive to minimise heat loss, and this cost is not carried by the end user. The main driver for the project was for financial savings on energy costs, but also to create a local market for woodchip, bringing unkept local woodland back to sustainable management, improving biodiversity and creating opportunities for local employment. Tariff digressions represented one of the most significant barriers to contend with, where due to the extended time needed to obtain planning permission and threat of further tariff digressions, groundworks had to be undertaken in the winter months. Other challenges included the negotiation of construction contracts, lease agreements, heat supply arrangements, and writing of a share offer, which were time-consuming and complicated. The second example is of Wheel Vivian in Constantine, Cornwall. The project replaced night storage heaters with individual ground source heat pumps linked to a communal ground array. 6 communal boreholes were drilled to a depth of 60 metres, feeding 12 individual 3 kilowatt shoebox heat pumps. Funding came from the Energy Company Obligation Scheme and from what was the Department of Energy and Climate Change through Cornwall Council. The primary driver was to reduce energy costs, whilst enabling each property individual control over their heat supply and energy contracts. The project was enabled through exceptional funding circumstances, affecting future replicability of the project. In this example, all the properties were owned by a housing association, negating issues of multiple owner consents. From examples in the UK, the integral role of a persistent and driven group to improve energy security and lower fuel costs in their community is evident within the majority of examples in rural areas. However, the low frequency of such projects and the challenge of their replicability indicates further barriers must be overcome. The challenges faced in increasing the deployment of low-carbon heat. Public perception and a lack of awareness. There is often a lack of awareness and interest in alternative heating technologies. The unfamiliarity of systems can cause a lack of confidence or distrust in comparison to more conventional heating systems. There is a need for a greater role of local authorities, community groups and charities to promote technologies, where at present the role is primarily undertaken by installers who have a vested interest in selling their products. Cultural norms. A tradition of and expectation to have individual heating systems with independent control is a common barrier for district heating schemes, where there can be an aversion to shared boilers or heating infrastructure. The perceived hassle factor. This is closely linked with perception and awareness, where the time, effort and potential disruption of changing a heating system can discourage people. A lack of confidence, reliability, and consumer protection mechanisms. Historically, heat networks have suffered from a lack of regulation, ability to change supplier, and a lack of support to address operational issues. Consumer protection for heat networks was brought in 2015, however there is more work to be done in this area. Insufficient technical knowledge and skills, including a lack of product standards and testing facilities. Given the fragmented nature of the heat network industry in the UK, feasibility is often undertaken by a mix of consultants, design and build contractors, and with maintenance through a separate operating company. Key design principles should be properly considered and implemented from initial feasibility through to operation in an integrated manner. There is a lack of companies that can deliver the whole journey from design and installation through to operation. Local authorities are well placed to own heat networks and maintain competitive prices, however a lack of resources and expertise limit them in doing so. Affordability. The upfront cost of replacing a heating system with a low-carbon alternative is off-putting to some and prohibitive for the lowest-income households. There is a lack of funding and finance to help people afford the upfront costs of installing a low-carbon heating system, and renewable heat incentive payments are retrospective. Capital costs of low-carbon technologies make installations a long-term investment, with risk increased for emerging technologies where technical lifetimes remain unproven. Occupants may not be planning to live in a home long enough to receive a payback on their investment through the renewable heat incentive. Running costs need to be comparable with alternative fuels to incentivize take-up, where long-term fuel savings are difficult to quantify and are not always enough of an incentive to pay more on any fuel bills in the present. Inconsistent signals from and availability of policy support and incentives. A defining feature of energy policies in the UK are their coupling to relatively short-term political cycles. The results are time-limited policies and incentives which offer little stability or incentive for strategic investment, nor the ability to make decisions based on a cost-benefit approach. Lessons and opportunities. Community ownership offers the opportunity to create a diverse, sustainable, and secure energy supply infrastructure under control of the local community and with profits returned to the local economy. National and regional policies and incentives are available in many EU examples to support farmers and foresters, for example, in developing supply chains, using local resources where there are synergies in energy production, resources and livelihoods. There is great opportunity to increase the resilience of communities in this way. The result is an increased sustainable use of natural resources, diversification resulting in increased employment and industry opportunities, with a renewable energy source for heat driven by and owned within the locality. Raising awareness of successful case studies is one potential tool for increasing acceptance and take-up of low-carbon heat. Information campaigns have been relatively absent in the UK compared to those EU member states with significant take-up. There needs to be a greater role of regional energy agencies to bridge the gap between national targets and local practices. This should include work with cooperatives and community groups to deliver information and knowledge, as well as to share best practice. Word of mouth and site visits were mentioned in the case studies as an important factor in gaining community support and achieving a multiplication effect for further projects. More effective finance mechanisms are needed, along with long-term funding and subsidies, to provide security and encourage investment in innovation that will decrease the costs of renewable and low-carbon technologies in the long term. Germany supports community and local energy through a diverse banking sector and small to medium enterprise lending programs. Approximately half the capital borrowed by energy groups is from cooperative banks and another third from development loans. The KfW Bank facilitates these loans, underwriting commercial banks as the government's intermediary and offering long-term loans at a 1% rate of interest. It is this financing mechanism that has unlocked many community energy projects and allowed for successful relationships between lenders and local borrowers. The longevity of the system and understanding of models by bankers has led to a high level of trust in the renewable energy sector. The Energy Efficiency and Renewable Sources Fund in Bulgaria offers a similar credit opportunity to assist with upfront costs, but can also act as a guarantor against other private finance. The fund operates as a revolving pot of money, which has been particularly successful in assisting smaller-scale projects. Similar examples have been seen in the UK with success in developing renewable heat projects. As an example of finance as an opportunity, the Revolving Loan Fund, operated by the Low Carbon Society, provides a financing mechanism specifically tailored to the needs of community renewable schemes in Cornwall. There is a gap in the role of local government for raising confidence and awareness, as well as in providing financial support to facilitate rural low-carbon heat in the UK. Local authorities do not have access to the staff, budgets or resources they need to act in a central capacity for community groups, private companies, local organisations and individuals. The development of municipal energy companies, such as in Germany and Austria, has meant municipalities can sell heat and electricity and use the revenues to reinvest into future schemes. Community ownership is recognised as an important factor in the creation of new schemes, where investment can increase capital for projects, as well as increase public involvement and acceptance. Member states with the highest levels of deployment of low-carbon heat have used significant carbon taxation as a policy tool to build low-carbon energy markets. This has often been accomplished by subsidies and support to replace oil or electric heating systems and stimulate demand for alternative technologies such as biomass, heat pumps, or through the implementation of heat networks. The UK has some of the lowest levels of taxes, levies and VAT on energy prices, particularly for gas, and this is reflected in the energy mix. Current taxes can go as far as to work against low-carbon policy, as carbon costs of gas are not reflected accurately in its price. Although many rural, community-led projects are still heavily reliant on grant funding to make them economically viable, Germany and Austria in particular illustrate effective relationships between devolved administrations, organisations, energy companies, industries and local actors. Projects are supported by national finance companies who are willing to invest in small-scale, low-carbon heat projects that, due to these proven and effective relationships, are no longer perceived to be high risk. A tradition of community approaches to influence change and a strong environmental agenda further supports this mechanism for delivery. Renewable and low-carbon heat can play a significant role as a part of a wider solution to fuel poverty. It is from examples of bio and renewable energy villages that confidence can be taken in the potential of low-carbon heat in rural areas to address social, economic and environmental challenges. Further resources available include the full report, a best practice guide, a policy brief and a poster resource displaying a basic introduction to low-carbon heat, definitions, targets and project examples. All of the resources can be found online under the Resources section of the Community Energy Plus website at www.cep.org.uk.